This is page 113 of the Incredibles book. We are doing section 2.4, the chain rule. The chain rule is used when you have a composite of functions, right? So here, what that means is you have a function inside of another function. So here you have f of g of x, where g of x is inside of f. And when you do that, you take the derivative of the outside. So that's where the f prime is coming from. Keeping the inside, and then you take the derivative of the inside and multiply by it on the outside. So we derive the outside, leave the inside, and then derive the inside. All right, that's the idea here. So let's look at chain rule. So what we're going to do is, on the left side, chain rule is not required. On the right side, chain rule is required. So on the left side, this is pretty straightforward. Y prime, the derivative of x squared is 2x. Derivative of 1 is 0, so that's gone. Here, I'm going to do a rewrite first, x squared plus 1 to the 1/2. So the outside function is the exponent of 1/2. The inside function is what we had here, right? The x squared plus 1. So y prime, we take the derivative of the outside. So the exponent, you bring forward 1/2. Keep the inside, so I haven't changed the inside. Subtract 1 from the exponent, that's regular power rule. And then take the derivative of the inside. The derivative of the inside is 2x, right? We just did a second ago. Derivative of x squared plus 1 is 2x. All right? Here, take the derivative. Derivative of sine is cosine. That's it for that one. What you may not be aware of here, there's two functions here. There's the sine, and then there's 6x. Right? So 6x is inside of sine. So when I take the derivative, you take the derivative of the outside, which would be cosine 6x, keeping the inside. And you're going to take this and multiply by the derivative of the inside, which is 6. This is better written as 6 cosine 6x. Okay. I forgot to simplify this one. So I have 2x here. I'm going to put the 2x in the numerator and put the 2 in the denominator. Right? That 2 is in the denominator. I'm going to put the x squared plus 1 to the negative 1/2 in the denominator, making a positive exponent. Now reduce the 2's, and I get x over the square root of x squared plus 1. Y, okay, that's it. I've simplified everything else. Y equals 3x plus 2. What's the derivative of that? It's 3. Here, I have 3x plus 2 to the 5th power. So I have an outside function of exponent of 5. So when I take the derivative, I bring the 5 down. Like regular power rule, I bring the exponent down. Subtract 1 from the exponent, so that's 4. Times the derivative of the inside, so that's 3. Now I multiply 5 times 3. So it's 15 times 3x plus 2 to the 4th power. Next one. Derivative of x is 1. Derivative of tangent is secant squared x. Right? No chain rule there. There's no composite functions. So here, the x is not composed with anything, so that one's okay. But here we have x squared inside of tangent x. So that becomes derivative of x is 1. Derivative of tangent is secant squared. Keep the inside of x squared, and then multiply by the derivative of x squared, which is 2x. Okay. The only thing about this, you can rewrite it with this 2x in the front. All right, this is not really any prettier, but more generally speaking, you put algebraic expressions in front of trig functions, okay? Because you don't want the algebraic expression to be confused with the angle of the trig function. All right, let's continue. So some of these require chain rule. So here, this one could be done with quotient rule, but if you rewrite it as x plus 1 to the negative 1, you can use chain rule. So when you take this, you're going to be y prime, you're going to bring down the exponent of negative 1 times x plus 1 to the negative 2, and then the derivative of the inside. Derivative of inside is 1, so just times 1. The rewrite would be negative 1 over x plus 1 squared. All right, here, this one does not require a rewrite. So I'm just going to take the derivative. The derivative of that is y equals cosine 2x, right? I took the derivative of sine, which is cosine, and now I need the derivative of 2x, which is 2. So it's better to be written as 2 cosine 2x. Here, I'm going to do a rewrite. Y equals 3x squared minus x plus 1 to the 1/2. And y prime equals 1/2 3x squared minus x plus 1 to the negative 1/2. So what I've done is taken the derivative of the outside, brought the 1/2 down, subtract 1 from your exponent, and then multiply by the derivative of the inside, which would be 6x minus 1. Okay, so all that is the derivative. All of that is the derivative. Now let's clean that up. So this has an exponent of 1. So I'm going to rewrite it with 6x minus 1 in the numerator. That 2 is in the denominator. And that is now exponent of positive 1/2 if I put in the denominator. So that means I can put in a square root. So it's 3x squared minus x plus 1. All right. And then here I got y equals tangent squared x. I'm going to rewrite it like this because frequently people get confused when they have the exponent in the middle of the function. All right. When I take the derivative here, that's going to be 2 times tangent x to the first power times the derivative inside, which is secant squared x. So that really doesn't clean up any. So I'm just going to rewrite it here so it's easier to read, but it's not really any better. 2 tangent x secant squared x. All right. All I did was rewrite it so it's neater. It's not, I got rid of the parentheses, got rid of that exponent of 1, made it so that you can read the x. That's about it. So that's page 113. Let's do these by pages.